Cast is now starting. All attendees are in listen-only mode.
Welcome everyone. Welcome to AWS and VMware webinar series, Modernize Oracle Databases and Application with VMware Cloud on AWS. I am J. Sampath Kumar. I am Partner Solution Architect focused on migrating enterprise Oracle databases and application workloads on VMware Cloud on AWS. I have Sudhir Balasubramanian co-presenting with me. Sudhir is a staff solution architect in Cloud Platform Business Unit, VMware. Sudhir specializes in virtualization of Oracle business critical applications. Sudhir is a VMware expert, member of a VMware CTO Ambassador Program, and an Oracle ACE. Just a gentle reminder, this is the 5th in the series. You can access the previous 4 webinars at your convenience from our AWS Partner Webinar On Demand website. Here's the agenda of the webinar. We will take a brief look into VMware Cloud on AWS. We will walk through the benefits and use cases of running Oracle workloads on VMware Cloud on AWS. Sudhir will walk through how to deploy and migrate Oracle workloads on VMware Cloud on AWS. We will wrap up with Q&A session at the end with some promotions. What does a VMware platform offer to run Oracle workloads? There are 6 major benefits of virtualizing Oracle workloads on VMware platform. Great performance, server consolidation and increased hardware utilization, accelerated provisioning of virtual machines, workload management including live migration, and 2 critical benefits for business critical applications, high availability and business continuity. When customers think about any cloud, they're worried about rework during migration. If you do choose a non-compatible cloud solutions, it ends up taking 60% of the migration cost and 90% of the migration time. So the customers like choosing like a integrated cloud. Okay, some customers want a hybrid cloud. They're looking at best of both worlds. They want all the benefits of the cloud, like scalability, on-demand provisioning, but skill sets of on-premise solution. This is where we talk about like the cloud contains like 60% of migration costs and 90% of the migration time when you choose your non-compatible cloud solutions. What are the common challenges with hybrid cloud adoption? Some of the common challenges that you see with hybrid cloud adoption are multiple virtual machine formats, incongruent networks, and operational inconsistency, okay, between your on-premises and VMware Cloud on AWS. And customers are forced to learn new skill sets and tools. And there is not a single pane of glass to view both your on-premises and your cloud solutions when you compare to control and monitoring mechanisms. So enter VMware Cloud on AWS. VMware Cloud on AWS is a software-defined data center that runs on AWS bare metal resources. It runs on sold, operated, and supported by VMware. It has got some support for containers and virtual machines as well. It offers on-demand capacity and flexible consumption as well. When you compare like an on-premises and VMware Cloud on AWS, to stand up a bare metal server, okay, it takes about roughly 86 days from consumption to cabling, racking, stacking, and adding it. In VMware Cloud on AWS, under 10 minutes, you can request for additional bare metal server and add it to your SDDC. VMware Cloud on AWS covers multiple global AWS regions. Quite recently, in March 2009, we launched in 3 new regions: in Singapore, Canada Central Region, and Europe Paris region. In the rest of the 2019, we will expand VMware Cloud on AWS to global regions. There are 4 use cases that we see from customer adopting VMware Cloud on AWS. One is data center extension. Second is disaster recovery. Third is cloud migrations. Fourth is next generation apps. We will look into each of those use cases in detail in the next few slides. The first use case is a data center extension. VMware Cloud on AWS provides an on-demand capacity. Customers can look into VMware Cloud on AWS as an extension of their on-premises data center. You can move your dev and test workloads during the project duration and deprovision them as the project ends. And also, it provides a scalable capacity for your containerized workloads so that you can meet your workload demands as it grows up and goes down. And also, you can use it for seasonal workloads like VDI, published apps, where it could vary every day. The second use case is disaster recovery. You can see your VMware Cloud on AWS as your disaster recovery site for your on-premises data center. Oracle workloads like physical standby can run on your VMware Cloud on AWS, replicating from your primary database on your on-premises. VMware Cloud on AWS can easily scale in terms of storage and compute. You can use VMware Site Recovery Services for replication and orchestration. If you do prefer traditional methods like Oracle Data Guard or Oracle Golden Gate, you can use this as well. Complementing your existing DRaaS solution with existing solution, you can use your VMware Site Recovery Manager or your vSphere replication. The major one which customer sees is cloud migration. You can migrate an individual application with a combination of application servers and database into VMware Cloud on AWS. You can also migrate a group of applications, which in case is most common with majority of our users because of integrations, to VMware Cloud on AWS. The third most pattern that we see in cloud migration is data center-wide evacuations, where they have an upcoming lease in data center getting ended quite soon. Customers do perform mass migrations to move to VMware Cloud on AWS. You can leverage AWS programs such as MAP, Migration Acceleration Program, for mass migration of a lot of workloads. And there are tools available to help you with the mass migration. We also have partners available to help you with mass migration. You can also consider VMware Cloud in AWS for your cloud migration during your next hardware and software refresh cycles. Or sometimes you might choose to re-implement your Oracle solutions like eBusiness Suite or Hyperion or PeopleSoft. The next new implementation could be on VMware Cloud on AWS. Having seen these use cases, what are the benefits of running a VMware Cloud on AWS for Oracle workloads? Number one is simplified migration. Number two is accelerated provisioning. And number three is application modernization. We'll see about these three benefits in detail in the next few slides. Simplified migration. VMware Cloud on AWS provides a seamless, low-risk migration option. It's a same stack that runs on both VMware on-premises as well as VMware Cloud on AWS. So it's a low-risk migration option. In combination with this, you have migration tools like HCX, vMotion, and you can use the traditional tools like Oracle Data Guard, or if you choose to do so, you can use Oracle RMAN backup and restore. You can migrate your single instance database quite easily with these tools from your on-premises to VMware Cloud on AWS. If you'd like to go through a hybrid cloud, okay, you can definitely connect your Oracle workloads on VMware Cloud on AWS to your on-premises VMware environments, as well as to AWS environments, like if you choose to run an application server on EC2, it can talk to Oracle database running on VMware Cloud on AWS. Also, you can facilitate data movement between an Oracle database running on VMware Cloud on AWS to your RDS instance running on your AWS environment. Many of our customers also have SaaS and PaaS integrations as well. You can also use your integrations to connect your Oracle workloads to your SaaS and PaaS integrations. The next benefit that we see is the accelerated provisioning. You can provision your entire VMware SDDC from scratch in few hours. If you choose to add new EC2 bare metal servers to your existing SDDC cluster, you can choose those as well. And you can create new VMs within minutes in your existing SDDC. Because of this accelerated provisioning, okay, the one immediate benefit customers will see, there is no more over-provisioning, and there is no complex demand forecasting for the next 1 year or 2 years. It helps customers to right-size the environment and keep the cost down. With accelerated provisioning, customers expect automation. We have support of Power CLI, we have API support, and if you choose to do some third-party tools, Puppet and Chef also is supported. The third most benefit that customers see is application modernization. Customers choose to re-implement down the line many of their business solutions. You can leverage native AWS services like Amazon Simple Storage for Oracle backups. You can do away with your legacy tape backup mechanisms, tape drives, and coordinating logistics of shipping tape back and forth from your backup site to on-premises or vice versa. Amazon Simple Storage service provides a storage mechanism for your Oracle backups. Customers running multiple web application servers can use Amazon AWS Elastic Load Balancers as well to load balance their web traffic, and also AWS directory services for managed directory AD services. Customers choosing to use a serverless framework can use AWS Lambda in conjunction with Oracle workloads running on VMware Cloud on AWS. Many of the customers choose to move data in and out of Oracle databases as part of their data warehouse or analytics services. You can use any of our Redshift, Amazon Athena, Amazon Kinesis, or for dashboards, Amazon QuickSight to move your data out of your Oracle databases or perform analytical services. So what solutions are covered in VMware Cloud on AWS? We have three major pillars with Oracle solutions. Number one is Oracle business critical applications like Oracle E-Business Suite R12, PeopleSoft, Campus, and Financial Solutions, Hyperion, Oracle Access Management, Oracle Identity Management, are also called as OAM and OID. Number two is your tech stack pillars. It could be Oracle databases, it could be Oracle WebLogic, or any of a replication tech stack like Oracle Golden Gate. The third most important thing that we see with customers is there's a lot of complex architecture pattern. Customers can run Oracle RAC or Oracle Real Application Clusters. They can choose Oracle Data Guard or Oracle Active Data Guard. and they can run Oracle WebLogic clusters as well. With these three things, I'm inviting Sudhir to take over and talk through the migration and deployment of Oracle solutions on VMware Cloud on AWS. Sudhir, please take over.
Thanks, Jay. So now let's take a look at some of the Oracle workload migration methods. So on a high level, Oracle workload migration from on-premises to VMware Cloud on AWS can be achieved in one of the two ways, either using the VMware Hybrid Cloud extension, also known as HCX, or using native VMware and Oracle methods. So with the very first approach, the VMware HCX abstracts on-premises versus cloud notions and presents capability to virtual machines as a continuous hybrid cloud, hence providing minimal operational overhead without requiring a retrofit of legacy infrastructure. So there are three types of HCX-enabled migration. The first one is the cold migration, where it integrates with the VMware NFC. NFC stands for the network file copy, and uses the same network path as SCX vMotion to transfer a powered off virtual machine. Essentially, the VM IP address and the MAC addresses are preserved, and the requirement here is the cold migrations must satisfy the vMotion requirements. The second type is called the HCX bulk migration, which basically uses the host-based replication to move a live virtual machine to and from HCX-enabled cloud sites or data centers. To reduce the downtime, the source virtual machine remains online during the replication, and it is bootstrapped on the destination ESXi host after the replication process completes. The third is what's known as the hot migration, where HCX vMotion, which is basically enhanced vMotion, can transfer a live virtual machine from an HCX-enabled vCenter to an HCX-enabled remote site, or from the HCX-enabled target site towards the local site. So with all these three methods, the current restrictions with the HCX vMotion is virtual machines with the following attributes are not supported for migration, namely, if the VM has a disk, a VMDK that exceeds 2 terabytes, or with shared VMDKs. So essentially, for Oracle RAC with shared VMDKs, we will have to use the second way of doing it. Next slide, please. Right. So as we saw in the previous section, right, how by using VMware HCX or the hybrid cloud extension, we are able to migrate Oracle workloads from on-premises to VMware Cloud on AWS. So this slide speaks about the migration approach, which basically uses native VMware and Oracle methods. So we can rapidly and easily migrate application workloads by extending on-premises data centers running VMware SDDC to VMware Cloud on AWS using the vSphere vMotion technology and back without any virtual machine conversions, without any application refactoring, and hence no application downtime, and without any networking changes, having the L2 VPN or the layer 2 VPN capability between on-premise SDDC and the VMware Cloud on AWS. See, the above points are key as many cloud providers require some level of refactoring to achieve the above, which is not the case here. Thereby, it saves a lot of time, effort, and man hours to try plan migration between on-prem and the cloud. So in this section, a single instance Oracle virtual machine on premises is successfully migrated to the VMware Cloud on AWS transparently in a couple of steps. The virtual machine is running Oracle Enterprise Linux 7.4 operating system with Oracle 12.2 grid infrastructure and RDBMS binaries. The Oracle ASM disks are created using Oracle 12.2 filter driver, ASM FD, and we use the multi-tenant option running a pluggable database. So as part of the migration steps, we choose the resource pool, the storage, the destination network port group, and then we are able to see that we are able to seamlessly and transparently migrate the single instance workload to VMware Cloud on AWS. Next slide, please. All right. So moving your Oracle databases and applications to VMware Cloud on AWS also enables to continue using Oracle Real Application Clusters, RAC, on the cloud. This is very important because simply moving your Oracle environment to AWS does not make it possible. but deploying on VMware Cloud on AWS allows to continue to benefit from employing this solution. The three following slides, they provide additional details on what this environment looks like. Basically, we start with an introduction to the migration process, a reference architecture of an extended Oracle rack on a stretch cluster for VMware Cloud on AWS. We need to keep this in mind. Oracle RAC has the following infrastructure requirements that are not directly available in AWS, namely shared high-performance storage accessible from all nodes in the cluster, and secondly, multicast layer 2 networking. VMware vSAN and NSX deployed into the VMware SDDC cluster, they meet those requirements natively, which then makes it a viable option to run Oracle RAC in VMware Cloud and AWS. So this slide, it shows a setup that uses an Oracle RAC database for high availability, zero downtime, client connection failover. It's basically supporting a Django Python application running in a native AWS Elastic Beanstalk environment. So this content was actually demonstrated in VMworld US 2017 in one of the sessions. So by leveraging the AWS Elastic Beanstalk service for the application tier and the VMware Cloud on AWS for the database tier, this end-to-end architecture delivers a high-performance, consistently repeatable, and straightforward deployment, better together. Next slide, please. So let's take a look at the example setup shown in the architecture diagram here. So basically, we have two on-premises vSphere cluster, Site A running production workloads, and a cluster in Site B that runs dev, test, disaster recovery workloads. Both Site A and Site B are in a hybrid link mode. Site A and Site B vSphere clusters have access to dedicated storage. Site A is connected via layer 2 VPN to VMware Cloud on AWS. The VMware Cloud is essentially in a stretch cluster deployment. So basically a 6-node stretch cluster across 2 AZs or availability zones, 3 servers in AZ1, 3 servers in AZ2. Storage in VMware Cloud on AWS is provided by the HCI vSAN instance. The current solution deploys 3 separate environments. Site A with a production 2-node Oracle rack, PD rack, as shown. Site B with a DR 2-node Oracle rack, PRDDG. And again, Site A has a production Oracle far sync as well. The Oracle rack on premises requires the shared VMDKs to be deployed with the multi-writer attribute. And the other requirement is the shared VMDKs have to be provisioned as eager 0 thick as per KB article 212.1181. The current restriction of multi-writer attribute is to disallow storage vMotion. So essentially the migration steps would be an offline Oracle rack migration. So the high level steps would be to shut down the Oracle rack. We power off VM1, VM2. On VM2, we remove the shared eager 0 thick VMDKs and storage vMotion VM2 to VMware Cloud on AWS. On VM1, we remove the multi-writer flag from the eager 0 thick VMDKs and storage vMotion VM1 to VMware Cloud on AWS. Unfortunately, what happens is the eager 0 thick VMDKs are converted as lazy 0 thick. So what we need to do is add new eager 0 thick VMDKs with multi-writer, the same size as the lazy 0 thick VMDKs, to VM1. We start up VM1, use the Oracle ASM rebalance to add and drop ASM devices, then go ahead and drop VM1 lazy 0 thick VMDKs, the older ones. And then on VM2, we add the new eager 0 thick VMDKs with the multi-writer at the same SCSI position and start the Oracle rack up. Next slide, please. So with VMware Cloud on AWS, essentially ESXi hosts by default, they reside in a single AZ and they are protected by vSphere HA. A feature called Stretch Clusters for VMware Cloud on AWS is designed to protect against an AZ failure. So applications can now span multiple AZs within a VMware Cloud on AWS cluster. I mean, as we all know, extended Oracle rack provides greater availability than local Oracle rack. It essentially provides extremely fast recovery from a site failure, and it enables all servers in all sites to actively process transactions as part of a single database cluster. running extended Oracle RAC on stretch clusters for VMware Cloud on AWS provides the same advantages as traditional Oracle RAC across data centers and sites, in addition to the AWS AZ level protection that stretch clusters for VMware Cloud on AWS provides. So an important aspect of any Oracle RAC configuration on VMware SDDC is to make sure or to ensure that the Oracle RAC virtual machines are not scheduled on the same physical ESXi server, because it basically negates the HA proposition that VMware SDDC has to offer. That is, the infrastructure level infrastructure level HA provided by VMware SDDC to complement the application level HA provided by Oracle RAC. So to achieve this, we need to specify VM anti-affinity rules for rack virtual machines, which forces the VMs to remain apart during failover actions. In addition to that, in case of an extended Oracle rack across multiple site or AZs, the best practice is basically to spread the Oracle rack virtual machines across multiple sites to ensure HA across the sites, in addition to the infrastructure and application level HA, which basically ensures that all Oracle RAC virtual machines do not land on the same site at the same time. So this is achieved using compute policies, tags, and attributes, which allows you to attach metadata to objects in the vSphere inventory. So the deploying and migrating of Oracle workloads from on-premises to VMware Cloud on AWS, this has been documented in detail in a reference architecture document, which will be provided in the resource section. Next slide, please. Well, to wrap up, the VMware Cloud on AWS brings VMware Enterprise Class Software Defined Data Center SDDC software to the AWS Cloud. Powered by VMware Cloud Foundation, this service basically integrates vSphere, vSAN, and NSX along with VMware vCenter management and is optimized to run on dedicated elastic bare metal AWS infrastructure. Keep in mind, we can rapidly and easily migrate application workloads by extending on-premise data centers running VMware SDDC to VMware Cloud on AWS using vSphere vMotion technology in back without any conversions, without any application refactoring, without any application downtime, without any networking changes, essentially having the L2 VPN capability between on-prem SDDC and VMware Cloud on AWS. And these above attributes are key, as many of the cloud providers do not provide that. So all Oracle workloads, including Oracle RAC, extended Oracle RAC, are supported on VMware Cloud on AWS. So the next step to take advantage of this is to contact your AWS VMware representative for building a POC or a pilot for migrating your Oracle workloads to VMware Cloud on AWS. Well, you can also send an email to aws-vmware-cloud@amazon.com. Next slide, please. All right. So we are running 3 promotions for VMware Cloud on AWS. The first one is a starter single host SDDC. So basically sign up for the single host SDDC and test out the service, build a POC or demo, and understand the features and capabilities of the service. Please note that this is not for production use. With the current promotion, you will get 20% off on the single host instance for the first 3 months. So basically, you'll only end up paying $5.60 per hour, and the offer is valid till 5th of June 2019. The second offer is production 3 host SDDC for the price of 2. This is another promotion where you will get 3 VMware Cloud on AWS host for the price of 2 hosts, and you can use these instances for production use. This offer is basically valid till 2nd August 2019. You can find more information about the offer pricing, the terms, the condition, etc. on the page on the link given. So just scan this QR code and it will take you to the pricing and the promotion page. Next slide, please. All right, so VMware Site Recovery Promotion. As you might know, the VMware Site Recovery is an add-on provided on top of VMware Cloud on AWS service used for disaster recovery use cases. Currently, we're running a promotion where you get free VMware Site Recovery add-on for up to 90 days for a max of 200 virtual machines. So you can learn more about it at that link provided. And of course, sign up for the promotion by scanning the QR code. Next slide, please. All right. So here are some of the important resources for VMware Cloud on AWS. Essentially, you can learn more about the service at the link provided. You'll also find information about the typical use cases, pricing, ecosystems, and many more learning resources. You can also get more technical information in the white papers. The links are provided as well. Essentially, the Oracle workloads and the VMware Cloud on AWS deployment, migration, and configuration guide. The Oracle database performance, VMware Cloud on AWS, which is basically a performance white paper. And also, we have a lot of blogs that talks about everything related to running Oracle on VMware platform. And that is something that you can find in the Oracle on VMware Cloud one-stop shop. It includes articles around running Oracle on VMware platform, from on-premises to running and migrating Oracle to VMware Cloud on AWS. You can also find tools related to total cost of ownership calculations for VMware Cloud on AWS. Essentially, the VMware Cloud on AWS pricing calculator that gives you an estimate of your costs for SDDC setup in VMware Cloud on AWS as per your business requirements. The second one is the Sizer tool, the VMware Cloud on AWS Sizer tools that helps you to size the environment as per your requirements. And third, the VMware Cloud on AWS TCO tool that helps you to compare VMware Cloud on AWS TCO with Azure and with native cloud instances. So please check out the latest VMware Cloud on AWS roadmap on the links as shown in the slide here. You can also follow us on Twitter at VMware Cloud AWS. You can also check out our YouTube channel that showcases the videos on VMware Cloud on AWS, service overviews, feature demos, webinars, as well as customer success stories. Next slide, please. All right, so now on to the questions and answers, and I'm sure you guys have a lot of questions.
I'm going to take one of the questions. The question is about using Snowball devices. So you can use Snowball devices to migrate your Oracle workloads to VMware Cloud on AWS. Basically, Snowball device gets delivered to your data center. You can take your RMAN backups. You can take your application backups to it. And then when you re-deliver it back to AWS, all these backups, which are written in an encrypted format, okay, gets moved to S3 bucket that you have predefined it. This S3 bucket is available in VMware VMs as an NFS mount point. AWS Storage Gateway makes this S3 bucket as an NFS mount point and makes it available inside a VMware VM. Then you can use that to restore your databases, your application servers. So this is one of the ways you can definitely use to do mass migration of your workloads in an offline manner. I think, Sudhir, there is a question about NSX.
Okay, so I think I see a question here. How does Oracle licensing work on VMware in AWS? When it's on premise, we have to pay for the entire vCenter, and the answer is absolute no, right? So the reason is this, right? When you look at the on-premises VMware footprint, and when you look at VMware Cloud on AWS, essentially it's the same platform. It's the same vSphere platform. So your Oracle licensing, which on premises can either be via the Enterprise Edition that goes on cores, or Standard Edition 2, which basically goes on sockets, or NUP, the same licensing model applies on VMware Cloud on AWS. Because keep in mind, right, when we say VMware Cloud on AWS, it's essentially running VMware Cloud on AWS bare metal infrastructure. So we are not running VMware Cloud on top of AWS EC2. You're running VMware Cloud on top of AWS bare metal servers. So the same licensing model that applies on-prem applies on VMware Cloud on AWS as well. The other thing to keep in mind that Oracle licensing does not go by network. It's not storage based. It's not memory based. It's not data center based. And of course, it's not based regardless of the state or the country or the galaxy that you guys are in, right? It essentially is based on either the compute, as I said before, Enterprise Edition, or SC2, or NUP seat based. So as long as you're able to adhere to that, you will be compliant with all your Oracle licensing. You do not have to pay for each and every cluster that's connected to a virtual center, regardless of whether it's running Oracle workloads or not. You only have to pay for those hosts where Oracle binaries are installed / and or running. Because if you were to look at the OLSA or the OMA, right, processors are defined as those processors where Oracle binaries are installed / and or running. So the emphasis is on the current usage of processors, not futuristic usage. So in a nutshell, Oracle licensing on-prem is exactly the same as Oracle licensing on VMware Cloud and AWS. And if you look at the one-stop shop link, there is an Oracle licensing blog on VMware Cloud and AWS that basically enhances this point and explains it in much further detail. All right. I'm not okay. Jay, was there another question?
Yeah, the question is NSX mandatory to perform vMotion from on-prem to VMware Cloud on AWS?
So I'm gonna say yes, and I'm gonna take that as an action item. But yes, NSX, you definitely need a direct connect, right? You definitely need a direct connect to go from on-prem to VMware Cloud on AWS, and HCX is one of the way that you're able to achieve it. Okay.
So I'm going to take one question on server migration service. So server migration service is to perform migrations to AWS native EC2. Okay, so you have good solutions like HCX, vMotion to directly perform VM migration from VMware on-premises to your VMware Cloud on AWS. You don't necessarily have to use a server migration service.
Okay, I think there are a couple more questions in the question window. So let's look at this one. Can you provide an actual link to the resource titled Oracle Workloads and VMware Cloud on AWS? Yes, that link is part of the one-stop shop, but definitely, Sonali, if you can please go ahead and provide the link in the chat, that will be great. While I look at the other questions here. What is the largest DB workload you can move to VMware AWS? So keep in mind, right, with the latest vSphere version 6.5, 6.7, right, your VMDK largest size is 64 terabytes minus 2 terabytes for metadata. And on top of that, the number of PV SCSI controllers and the number of VMDKs have actually doubled and quadrupled over the couple of years. So you can essentially go up to 64 VMDKs times 62 terabyte per VMDK. So yes, we can migrate as large an Oracle database workload as you can. Keep in mind, the migration time depends upon a lot of factors, right? Of course, it depends upon the pipe, the kind of bandwidth that you have from your on-premises to VMware Cloud on AWS. And that's pretty much the same if you were moving your database or if you're moving a data from one data center to the other. Most of it is, of course, network dependent. So the other question was, how can we get the links presented in the presentation? The presentation and the presentation will be made available to you guys after the webinar. So definitely you guys can take advantage of that. Apart from that, Kate, Jay, am I missing any other questions here?
Yeah, so I'm just going to have one generally addressing questions because there is some leaning towards like POCs. So if you do engage either a AWS representative or a VMware representative, so we have partners who can help you with migrating Oracle workloads. These could be license review partners who can review your license review contracts as well, and as well as migration partners who are very experienced with VMware Cloud on AWS and VMware on-premises, plus they have quite a deep knowledge about Oracle workloads. So, so who can give you the necessary know-how, knowledge, or even assistance during your migration.
Okay. So I think we have two questions which are very similar. One was, how do you protect customers from Oracle licensing applications, right? And the other one was, what about the Oracle licensing rules on VMware? Do they apply here as well? The answer to both of them is yes, as long as you adhere to the Oracle licensing rules on-prem. Essentially, I've already said that licensing rules on-prem is no different than licensing rules on VMware Cloud on AWS. Please look at the one-stop shop, the blog post. It has all the necessary links that that speaks about Oracle licensing on-prem and also Oracle licensing on VMware Cloud on AWS. So the name of the game is to make sure that either we go with a dedicated cluster, vSphere cluster, or a shared vSphere cluster with a must affinity rule. That way, we are able to now create an effective compute enclosure, which will help with the Oracle auditing and to prove the fact that we never vMotioned or storage vMotioned our virtual machines out from this compute enclosure, right? So please do have a look at the links. Again, those links will be provided as part of the presentation.
And there is one question for support for SAP on VMware Cloud. Okay, please reach out to your AWS or VMware counterpart. We are definitely looking into it for support for SAP on a VMware Cloud. This is something that we are already working on, irrespective of what the database is. Is it Oracle, SAP, HANA, Sybase, or whatever this thing? But as a SAP, as an application, we are definitely working on it. Please reach out to AWS or VMware representative for the time.
Yeah, there was one more question. This solution, or I don't know if that's a comment, right? This solution does cover to those who do not want to move all the Oracle environment to the cloud. I just want to confirm that's correct. I mean, you can move some your Oracle environments to the cloud, either single instance or Oracle RAC. So basically, you either have one of the two ways of doing it, either using the infrastructure way of doing it, which is basically using the hybrid cloud extension, HCX, or if you wish to use the Oracle native and the VMware native way of doing it, the deployment guide, which is essentially 150 pages in size, essentially covers every detail of it. So an example is a two-node Oracle RAC 12.2, essentially, which has all of the greatest in the wills and bezels of 12.2, right? And I put in all the steps as to how you're able to move it from on-prem to the cloud. So again, the choice of moving all or none is completely dependent upon the customer. Okay, where is the one-stop shop you're talking about? So if you look at the resources page, again, the webinar will be made, the presentation will be made available to you. There is a link, right? The one-stop shop link, and that's essentially a blog that I come up with that has, it is basically a pointer to all the collateral, Oracle collateral that we have on VMware. So again, that will be provided to you guys.
There is a question about EBS storage. So currently we have i3 bare metal, okay, with NVMe storage. In the future down this year, okay, we are also looking at R5 metal with AWS EBS storage attached. That is definitely in the roadmap that is going to come up shortly.
Okay, how does database patches are handled on AWS VMware? The same way that you would handle your database patches on your on-prem. So, typically you have the Oracle DBA team in the customer Oracle DBA team handling database patches on-prem. That they would do the same thing as on VMware Cloud on AWS. So keep in mind that AWS is on the hook, or they are responsible for maintaining the infrastructure. The applications, the same way that you handle them on premises is how you will handle them on VMware Cloud on AWS. I mean, this is kind of different than the RDS on VMware Cloud, RDS option on-prem, right? Wherein Amazon has you give Amazon the choice of managing your Oracle workloads, right? If that's not the case, then the same way that you manage your database patching, your configuration, installation, your data masking, refreshing, cloning on-prem is exactly the same way that you would do on VMware Cloud on AWS. So the other question, I don't know, Jay, if you have answered it, can I migrate virtual VM server from on-premise to AWS VM without using EC2 as compute? If I'm getting a question correct, yes, that's what the VMware Cloud on AWS is. You are able to migrate your virtual machine from on-premises running VMware SDDC platform to VMware Cloud on AWS, right? And you will be basically either using an enhanced vMotion, using HCX, or using the mix of Oracle and VMware native methods, moving from on-premises to the cloud. So essentially, you'll be on the VMware platform. And then
so
go ahead, please.
No, go ahead. Finish your
thought. So once you're on VMware Cloud on AWS, you have the option of using native AWS services. Like you can use EC2, you can use EBS, EFS, and Jay, please add to it.
Yeah, so EFS is definitely available. Then EBS is definitely we are looking to add a native R5 metal storage. Also, EFS is definitely available, and you can make an S3 as an NFS mount point, which is quite popular with Oracle backups. And to address another related question, the way you take backup here in this VMware Cloud on AWS for Oracle database is exactly the same RMAN script, okay, that you take your level 0, level 1 backup, incremental backups, or full backups, you dump it into an NFS mount point. Okay, this NFS mount point basically gets replicated to your S3 storage bucket. Okay, S3 storage bucket is our native object storage mechanisms which can retain your backups for a long time. Okay, and let's say there are some customers who would like to retain backups for let's say 7 years, 10 years. S3, you can trigger policies in S3 where, let's say, this backup which is more than 30 days, you can move directly from S3 to Glacier. Okay, and it gets into archival mode for like 7 years or 8 years or 10 years. When you want to recover it, it is much faster than tape solution. Okay, within a matter of 1 to 4 hours, you can restore the entire 7 years or 10-year-old backups, and it's made available in a VMware VM through an NFS mount point. So that's a quick overview of the backups in this VMware Cloud on AWS.
Right. And I think there was another question from Arun, and that was, does VMware Cloud on AWS support Red Hat GFS? Answer is yes. Again, look at that one-stop shop that I keep saying again and again. It's the link will have all the links, including links onto vSAN, vVols, VMware Cloud on AWS, vSphere links, Oracle best practices link, Oracle Rack deployment guide. It also covers third-party clustering solutions, right, from Red Hat, from Veritas, from IBM, and also from HP. So please have a look at that. And yes, VMware Cloud on AWS or even on-prem supports Red Hat GFS.
There's a question about NVMe storage. NVMe storage is local hardware attached storage. Okay, that's being virtualized by VMware vSAN. Okay, it's not a third-party storage. It's a storage that is being provided as part of i3 bare metal servers by AWS infrastructure.
I think there was another question about, are you looking to offer anything similar with other cloud providers, such as Oracle Cloud? So as of this point of time, officially, I am not aware of any such moves, but definitely if there's something in the offerings, you guys will be the first to hear about it. All right. How about file system monitoring? Do we have to use OEM for ASM monitoring, or does AWS VMware have any tools to do the same? So you guys keep one thing in mind, right? No Oracle tools or any of the Oracle tools that we have been using so far, right? Whether it's the $V sessions, whether it's the X dollar views, or whether it's the ADDM, whether it's the AWR or the ASH, the ASH reports, the active session history reports, or even the OEM, that doesn't go out of the window when one virtualizes Oracle workloads on VMware platform. You will be using the same tools of the trade, right? So you could, if you have OEM in shop, please continue to use OEM to do the same monitoring as you've been doing it on-prem or even on your physical infrastructure. So yes, you can use to do that. In addition to that, right, we have a product called vRealize Operations, and vRealize Operations basically uses or can use a adapter from a third-party company called Blue Medora. It's called the Blue Medora adapter. So essentially, the adapter, right, is able to plug into your Oracle Enterprise Manager, and it can log on to the satellite databases managed by the OEM to extract any metrics that an Oracle DBA is interested in, and display it in the dashboard for any kind of troubleshooting, forecasting, or any kind of capacity planning thing. So again, the adapter doesn't have to go against the OEM database. It can also go against a standalone Oracle database per se, right? So you can use OEM along with the Blue Medora adapter with vRealize operations to essentially extract metrics from all layers of the stack so that you have a contiguous view of all of your layers. So it helps you with your performance troubleshooting, monitoring, capacity planning or forecasting, and so on and so forth.
There is a question about AWS DX. Yes, Direct Connect is supported, and it's one of the preferred way instead of VPN. VPN has got its own limitations if you are trying to move massive amounts of workloads, or there is a massive amount of communication between your on-premises and VMware Cloud on AWS. You could use AWS Direct Connect in conjunction with VMware Cloud on AWS.
And I think there's another one, Ajay, in addition to that. If we were to enable jumbo frames on AWS DX, can NSX take advantage of the increased jumbo frames, assuming all hardware is configured properly?
Yes, Direct Connect and generally Direct Connect and AWS infrastructure supports jumbo frames. So NSX, I'm not sure. I think you can take up that answer.
Yeah, so like I think Gary Hamilton from VMware already answered, right? You don't need an NSX between the on-prem and the cloud. So essentially, you can use SCX to do it. But the VMware Cloud on AWS essentially, right? If you look at it, it's VCF, which is VMware Cloud Foundation, and NSX and vSAN underneath the covers. All right, let's look at another one. And of course, there was one question like, will the webinar be archived and be online? I missed some of it. Yes, it will be. Yeah, you guys will get an email with the link.
There is a question of AWS Outposts. Okay, so there are Outposts is like comes in two editions. One is a VMware edition, and other is AWS EC2 edition. Okay, pretty much a VMware edition is going to run a VMware stack. That means it is going to be compatible with your VMware Cloud on AWS. Even if you choose to use AWS edition of AWS Outpost, okay, you can use technologies like Oracle Data Guard or Oracle Golden Gate, which are agnostic to any of the underlying hardware. So you can still replicate your on-premises to VMware Cloud on AWS or VMware Cloud on AWS to on-premises as well.
Okay, we have another question from Hemant. Will it be possible to perform L2 extension in case of AWS Direct Connect? Jay, can you take that one?
Yeah, so yes, L2 extension, we have seen customers performing it. The reason being is customer wants to bring their own IP addresses, okay? So L2 layer extension is definitely possible, okay? And the one thing is I need to double check on it is L2 extension over Direct Connect. Okay, this is something that I need to check, and I will get back to, in the forum.
I mean, that's the whole reason of having this L2 VPN or the L2 extension is essentially to make sure you don't have any application refactoring. So adding to what Jay said, there is no application refactoring, there is no IP address changes, because if you look at most of the migration things, right, 90% of the migration, whether it's cost or time, is basically just to do application refactoring. So the very fact that you're able to keep your hostname, the very fact that you're able to keep your IP addresses, the very fact that you don't have to change anything in that it is a seamless and a transparent move from on-premises to VMware Cloud on AWS. The simplicity, that's the entire value proposition of VMware Cloud on AWS. All right, do we have any more questions?
I think we are good.
Thank you, John.
Okay, that's it, everyone. Thanks for attending this webinar. The resources and the presentation site will be available to you over email. Thanks for attending this session of the AWS VMware webinar.
Thank you. Thank you very much.